We're comparing means. The best way to visualize a means comparison would be to make a bar graph or a column graph of the means. We've seen the descriptive statistics, the central tendency and the variability in SEEIT. We need to transfer that to Excel. It's probably easiest just to calculate them here in Excel. Let's set up our summary table for our descriptive statistics. In cell L2 here, I'm going to type the label average. I'm going to hit the tab key to move across to M2 and type the label standard deviation. And in N2, I'm going to type sample size. In K3, let's have the label actresses. I'm going to go ahead and add the n equals 25 because remember when we make the graph, we're going to need that. And the actors, n equals 25. All right, I'm ready to fill this in. So in cell L3, I want the average age of this sample of actresses equals average, open paren, click and drag across the data and close paren. Let's do it a slightly different way for the actors. In the same way, just a slightly different way of entering it. I'm going to insert a function. Under my formula builder, I'm going to start typing average. I'm going to insert that. I'm just going to select the whole column F. Let's see if that works. Yep, that worked just fine. So here I want the standard deviation. I'm going to start typing equals standard deviation. Just stdev is the function for the actresses. And I'm going to do the same for the actors. Standard deviation for that group of actors. I'm just going to verify my sample size using count. So the function is equals count, open paren, click and drag over the cells, and then close paren. I'm going to click and drag over the labels and the data, and under the insert ribbon, choose just a clustered column chart. And there's the basic chart of the means comparison. The other piece of information that you want to include on this chart are the error bars. Those are those I-beams that extend symmetrically above and below the mean of this particular sample. Because just like we've been saying, right, every time we draw a sample, it's going to be slightly different. So this is our mean of this particular sample, but we would expect the samples to fluctuate within these standard error of the mean, within those I-beams. It's another way of saying that this was the particular sample. We're confident that the underlying population mean falls within that standard error, so plus or minus a certain amount. We calculate the standard error of the mean based on the standard deviation in this sample and the sample size. The formula is the standard deviation divided by the square root of the sample size. Let's add that calculation to our summary table here. So I'm going to type the label standard error. Let's enter that function. I'm going to start with an equal sign. I'm going to click on the standard deviation. And then I'm going to type the divided by sign, the division sign. Now I need the square root of the sample size. Excel will do that for me. If I start to type the word square, it pops up square root. So I'm going to select that, and it's asking me to put in the square root of what? Where's the number for that square root? So I've ended up with the formula equals M3 divided by SQRT open paren N3 close paren. And I'm going to type an enter. I want to calculate the same formula relative for the actors. I can use fill. I'm going to fill that down. We need to add these standard errors to this chart. So let's click on that chart. And under the chart design, we're going to choose to add a chart element. We're going to choose those error bars. So at the moment it's none. And then there's standard error, percentage, standard deviation, and more options. Standard error sounds like what we're doing, but it's not. Excel hasn't got the information in that chart to calculate the standard error. And so if we add Excel standard error, I'm not entirely sure what it is actually adding. We've calculated our standard error. They're different for the different groups. Let's come under that more error bar options and add that exactly. So over here, we've got format error bars. We want it to go in both directions. We want it to be symmetrical above and below the mean. Let's have a cap so that it looks like that standard I bar. We're going to come down to custom and choose specify value. It's asking us for the positive error value and for the negative error value. We want it symmetrical, so we're going to put the same thing in for the positive and for the negative. And we want it to be different for the actors than for the actresses. So we're saying for the positive error value, we're going to come and click and drag over cells O2 and O3, no, O3 and O4, which is where our standard error calculation is. And we're going to do the same thing here for the negative error value. I've highlighted what is in there, and I'm going to come and click and drag over our calculated standard errors, and I'm going to click OK. So it's added our standard error bars. The one for the actresses does seem like slightly larger than the one for the actors, which would be right because that was nearly 2 and this was only 1.39. But let's just prove to ourselves that they are reflecting these numbers here. So what if our calculated standard error for the actresses had been 8? Did you see the chart update? And so the chart has updated where it is now, yes, 8 above and 8 below. That wasn't accurate. We were just proving to ourselves that they were drawing from that data. So I'm going to go ahead and do Command Z to undo that. So what does that standard error mean? You've probably heard this sort of idea of margin of error, particularly in an election year. You might say, you know, we're ahead in the polls by 14 points plus or minus 3%. So that idea that we've got a sample and we know it's not exactly the same as the population, but we're pretty sure that the population is between plus or minus some percentage of this sample, or in this case, some standard error of this mean. So we could use the average that we've calculated and the standard error to calculate what our likely population mean is. Let's do that. So here I'm going to type the title low, and here I'm going to type the title high. That we think that the population mean falls between a low of the average minus the standard error, and that the high falls between, the high is the average plus the standard error. And I'm going to fill down. Now again, we've actually got this population, so we can double check. We won't always have the population, but for right now, we're just proving to ourselves that these samples are drawn from this population, and that we can get useful information from a sample. What is our actual population mean? If you don't remember, we calculated this back in tutorial 4 or something, but we can go ahead. I can just tell you that it was 36.84 for the females. Did we get it? Does our actual population mean fall between the low and the high estimate that we estimated? It does for me. Does it for you? And for the males, the actual population mean was 44.43. Ooh. It doesn't fall between it. It is just slightly below. Huh, how about that? That won't happen very often. I would imagine for most of the samples that you drew, the actual population mean falls between our standard error. I think another way we would look at these standard errors is that we would say that we are 95% confident that our population mean falls between these two numbers. We don't ever claim to be 100% confident because we draw samples like this. It's not far off though, is it? A good rule for visual reasoning when you're looking at a chart with error bars is to ask yourself if the error bars overlap. Why would we do that? What would it mean if our errors bars don't overlap? Sure, it would mean that we're really confident that the population for this, for the actresses, falls within this range, and we're really confident that the mean for the population of actors falls within this range. And if they don't even overlap, it's very unlikely that they're drawn from the same population. So the visual reasoning skill here would be to look at those, and if they don't overlap, you could be pretty sure that we're going to conclude that these are from different populations. Go ahead and adjust your chart format. It's going to need a title. Be sure you include the word average. It's going to need axis labels. It's going to need the scale. Ask yourself these questions. Do you remember? Do you need space between these bars, or should they be touching? Should all the bars be the same color? Are they all representing the same data? Go ahead and copy and paste when you're happy with that formatting. Copy and paste that chart into Word and write a sentence or two that interprets the relationship between these groups. You want to be sure to work that into the sentence where you had the descriptive statistics. Next, why don't you practice what you know? Why don't you recreate this for the two groups of actresses? Are you going to do it on your own, or are you going to watch me do it? Do you remember what the standard error of the mean, the calculation is? It's the standard deviation divided by square root of the sample size. And so we think that our population mean is between a low of that and a high of that. I'm going to go ahead and fill that down. And for both of these, we know that the average, the actual population mean was that 36.84. What happens when we graph this data? I'm highlighting the labels and that the averages, and I'm coming into my insert ribbon and choosing a clustered column. Wow. Excel is really exaggerating a small difference. It's been really very deceptive, isn't it? So if we look at the scale on the y-axis here, it is zoomed right into between 37.28 and 37.42. It is absolutely exaggerating that difference. And so we need to be very careful using our visual reasoning skills to check that we're not exaggerating a small difference. What happens when we add the error bars? So let's add, say, more error bar options, custom, and we're going to specify those values just like we did before. Okay. So already Excel has had to zoom out. It still hasn't zoomed out very far. We would almost certainly want to set that scale. Let's have a look at what it looks like if we go all the way to a scale of 0. Yeah, that's probably the most accurate way of just depicting that data. For a bar chart or a column chart like this, we don't have to start at a 0 baseline. We can truncate it, but you probably only want to truncate it if it's, 1,000 or 3,000. If it's under 50 like this, you probably want to include 0 as your baseline. Using our rule of thumb about the standard error of the mean bars and the overlapping, if you just looked at these, would you think that these were 2 samples drawn from the same population or 2 samples drawn from different populations?